Hello everybody, today starts the first day of our next section, brand new section on compound inequalities. The focus of today will be a skills refresher on using compound inequalities, specifically a focus on the words and or. And hopefully this rings a bell a little bit from last year. It is prior knowledge, but we will definitely be bringing it back and practicing a lot in these notes and then in class tomorrow. The attached part that says homework is not part of these notes. That's for tomorrow's class. So if you have not grabbed a highlighter yet, please go get one. Pause. I will be highlighting in the notes. Let's start with our definition of what a compound inequality actually is. A compound inequality is two or more inequalities joined by the word and or the word or. The solutions are either between two numbers that would be an and situation, or fall into one or the other solution sets. That would be an or situation. We have some nice notes written here for us on the front page. We'll be just talking through most of it, move through it pretty quickly because, again, this is a skills lesson, a refresher lesson. The and inequality can look like one of the following. So there's two examples. Here's one, and here's the other. Let's talk about this first one. What we just highlighted here, it means x is between 0 and 4, and we read from the middle. You've heard me say that before. Let me bring that back. So look where I'm pointing. We're going to read from where x is. In this case, x is in the middle. So we say x is greater than or equal to 0 and less than 4. Let me say that again. X is greater than or equal to 0 and less than 4. Bringing back our interval notation, we should hopefully remember way back in Unit 1 when we were writing domain. If it was set notation, you used this setup, this inequality setup, or a combination of brackets and parentheses. A key piece to remember, the inequality symbols will both be either less than or less than or equal to. It'll always be one of these two. Kind of like way back when we did, you don't have to write this down, but remember the setup for set notation was like this, and your job was just to fill in one of these two numbers, and these inequality signs always pointed this direction, x greater than this, less than this, and you just had to decide if you needed a bar. Same idea. The inequality signs will always be less than or equal to, because you're reading from the middle. So when you read from the middle, this is actually saying x is greater than this and less than that. Let's graph it. So if I were to graph this, we need the numbers 0 and 4. So maybe I start 0 right here. 1, 2, 3, 4. It doesn't matter where you put it as long as they fit. and you're obviously counting by ones. Like I can't just say, ooh, 0, and then 4 is right here. No. Count by ones and make sure 0 and 4 fits on this number line. X is greater than or equal to 0. So that's going to be a solid dot on 0. And open circle on 4. Greater than 0 and less than 4. The only values that satisfy what we just said out loud are between 0 and 4, just like this. So any number between here and here works. Notice it's an open circle on 4, so the closest you could get to this is like 3.9999999, just not 4. Looking at the second example, the other way that this could be is instead of having X in the middle, it could actually be written out with the actual word and as part of it. So this means X is between -9 and -5. It's not as obvious, like in this notation, it's clearly between these two numbers, but as soon as we graph it, we'll see what we're talking about here. So on this number line, I need to fit -9 and -5. So I'm going to try starting from here, and we'll see if I make it. If not, we can erase and try again. So -9, -8, -7, -6, -5. Oh, okay, I made it. Maybe put a couple more that way. This would be -10. So X is greater than or equal to -9, so heading in that direction. And X is less than or equal to -5. Just these values. Now last year in Algebra 1, it's possible that when you guys drew, I'm just going to put a rough sketch right here. Some of you may have actually drawn it like this. X is greater than or equal, it's a little high, let me lower that a little bit. X is greater than or equal to -9 like this. And then maybe in another color, X is less than or equal, and then maybe you shaded the other way. And then when it was an and, you just keep what they have in common. So like you maybe darkened this to be more obvious and or erased this other piece. In Algebra 2, I would like us to just be able to jump to having this graph be our answer right away. Time to talk about OR, the OR inequality. Can only look like this. So if it's an OR, it's going to say the word OR. This means n can either be larger than 1 or less than -3. And here's the key part. It doesn't have to meet both criteria, just has to meet one of the two. So I see that I have 1 and -3. So we need 1 and -3 to fit on the number line. So -3, -2, -1, 0, 1, there's 1. Maybe I just go a couple more to either side. N greater than 1, so open circle on 1, greater is to the right, or N less than -3. So if N is greater than 1, it's a solution. So if you were asked, is N equal, that's supposed to be an N. N equals 10. Yes. Because N equals 10 is greater than 1. It would fit into this shaded solution set that goes forever and ever this way. What if somebody asked you N equals -8? This would also be a yes, because -8 is part of this shaded solution set. So that's what we mean by a value of N is a solution if it satisfies one of the two, this one or this one. And the inequality symbols can be any two of the four symbols. It could be any combination of any of the possible inequality signs. That's different than the and situation. Up here, for and, when it's written this way, in this particular notation, they both have to be in that direction. If it's written with the word and, then it could be a combo. But I would again recommend think back to remember set notation on that. Okay, so we've talked about and, we've talked about or. We just have a couple brief notes here on our graphing. Each inequality is solved separately and then graphed on a single number line. We're about to practice that. Continue to use your open and closed circles. So when we graph these examples, we're working with closed and open circles just like we were before. This is a key summary point, so to speak. The and inequality will be a graph of what the two equations have in common, only what they have in common. So when I put up that picture here of what you did last year in Algebra 1, where you graphed one all the way, graphed the other all the way, and only kept the piece in the middle that they have in common, that's what this represents right here. The or inequality will be a graph of the two inequalities. So we graphed one inequality, which got us this half, and then we graphed this inequality that got us the other half. So with or inequalities, we will have two pieces. Let's practice. Numbers 1 through 4, we're given the graph, and we need to write to the inequality. So take a look at number 1, and mentally I would like you to vote. Is this an and, or is this an or? Well, as soon as I see that I have two pieces, I know that this is going to be an or. So I write x is, just look at this piece, going to the left, so less than, it's a solid dot, so less than or equal to -8, or I have to write the word or x is, here this is going to the right, so greater, it's a solid dot, greater than or equal to, this is 8, this is 12, and if I look, it looks like we're counting by twos, 0, 2, 4, 6, 8, 10. X is greater than or equal to 10, and I'm done. In number 2, I see that my values for x are clearly in between two values. So x is going to be greater than a value and less than a value. You can actually kind of put x here if it helps. These are my values of x. X is greater than -1. And I'm going to leave that without a bar because I see an open circle right there. And x is less than or equal to, solid dot, 5. X is between -1 and 5. Number 3, try on your own. Make a decision. Is it an or is it an and write the inequality. Press pause. Actually try 3 and 4 on your own. 3 is an and because I clearly see it's between two values. And again, if it helps to put x so you can see what it's greater than and what it's less than, do that. So x is greater than -10. This is also counting by twos. -10 is halfway between -8 and -12. I do not put a bar because it's an open circle. So x is greater than -10 and less than, this is interesting, it's not 10 because 10 is right here. This is 8. So halfway between 8 and 10 is 9. Number 4, I clearly see two pieces. Here's one piece, here's another piece. So right away, that tells me that this is an or inequality. So x is less than or equal to, because it's going to the left, and it's an or equal to solid dot. This is counting by ones. This is -4, -5, -6. So x is less than or equal to -5, or x is greater than 0. Now we're ready to practice solving. And all of that hard work that you've put into these first couple days of this, in 4.1, with how you showed work, it's all going to come back and pay off here, because the directions are solve each compound inequality and graph the solution. To make a point, how would I say this? So in 4.1, there was not a second inequality. You just had this. Or the directions were just to solve this. Now we are going to solve both, one at a time. So let's draw a line down our inequality sign. For right now, I literally want you to pretend like this one does not exist. So if it helps, like put your finger on it, cover it up. We're only looking at this one. We are solving for r, and if it helps, you can very carefully, don't highlight the whole thing, just highlight the variable. We're trying to get r by itself. To get r by itself, I see that I have a positive 1 here. I'm going to subtract 1 from both sides. So this becomes r is less than or equal to 4 minus 1 is 3. This piece is done. Now we're going to ignore this side for right now and come over here and solve this one. Again, if it helps, very carefully highlight the variable. This is what we're trying to get by itself. I see that there's a -6 here that I can add over to the other side. This crosses off because it's 0. Crosses out, it's 0. R is greater than or equal to -8 plus 6 is -2. Here's my answer. I got and because it was an and to begin with. We can either write it as r is less than or equal to 3 and r is greater than or equal to -2. We can actually translate it into this. Reading from the middle, this is the r is greater than what side? Well, I look, r is greater than or equal to -2. So r is greater than or equal to -2. And then this is the r is less than something side. When I look, r is less than or equal to 3. So this and this mean the same thing. It's nice that I have my number line. It's got the numbers on it. Yay. Choose which one you're going to use to graph. We should get the same graph. R is less than or equal to 3. And r is greater than or equal to -2. In other words, r is in between -2 and 3. And we are done with number 5. Number 6 is an or example. Again, you're going to pretend like you have 2 pieces. This is our first piece. So right now, mentally, completely ignore this. Line down your inequality sign. If it helps, very carefully highlight n. How are we going to get n by itself? Well, I see that there's a subtracting 4s happening right here. So the opposite of that would be adding 4 to both sides. We get n is greater than or equal to 5 plus 4 is 9. This piece is all done. Let's come over here, line down the inequality sign. Now we're going to completely ignore this and just pay attention to this one. Solving for n right here. If there is something that you can add or subtract, you have to do that first. So this says 6 times n minus 5. We can take care of this minus 5 first by adding it to both sides. This is 0, so now I have 6n less than, Negative 5 plus 5 is 0. The opposite of multiplying by 6 is dividing by 6, so I'll divide both sides by 6. N is less than 0. Come back to the original to know if you have an and or an or. This was an or. So I write this, n is greater than or equal to 9, or n is less than 0, and we're done. So if it works out that it's all lined up this way and you can just put it in a box, that's nice. I do not want to see some like jigsaw puzzle box trying to group these together. Write it as a nice statement. And now we're ready to graph. It's an or, so I know I will have two pieces. N is greater than or equal to 9. That'll be a solid dot to the right. N is strictly less than 0. So open circle on 0, less than is to the left, and we're done. Number 7. Let's take a look at number 7. Neatness is key on ones like number 7. We have two inequalities, so we are going to have two lines down the inequality signs. If you haven't been highlighting yet, this might be a good one to highlight, because as crazy as all of this looks, we're going to pay attention to the middle. This is what ultimately we're trying to get by itself. So our job is to get x by itself here. I see 4x minus 7. In the middle, if there's something you can add or subtract, we need to do that first. So I see minus 7, so I want to add 7. If we add 7 here, we have to add 7 here and here. Negative 39 plus 7 is negative 32. Keep the inequality signs just the way they are. This is now just a 4x in the middle. And then on the far right, negative 31 plus 7 is negative 24. Again, our focus is on x. This says 4 times x. What undoes multiplying by 4? The opposite of multiplying by 4 is dividing by 4. So I want to do this. I want to divide by 4. But if I divide this piece by 4, I need to divide this by 4 and this by 4. What gets done to the middle has to get done to both sides. In the middle, this just becomes x. Negative 32 divided by 4 is negative 8. And negative 24 divided by 4 is negative 6. And we are done. If it helps to see it without those lines, we just rewrite it underneath. X is greater than or equal to negative 8 and less than or equal to negative 6. You know you're done when x is by itself. Let's graph. This is an and, so I know x is between two numbers. So open circle on negative 8. X is greater than negative 8 and less than or equal to negative 6. Number 8 is an or. We have two separate inequalities, so for right now, completely ignore this one. Let's just work on t divided by 6 greater than or equal to 0. The opposite of dividing by 6 is multiplying by 6. Very carefully put each side of the inequality in parentheses and show multiplying by 6. Multiplying by 6 and dividing by 6 are inverse operations. They cancel out. So this is just t. Keep the inequality side the same. 0 times 6 is 0. T is by itself. We're done. Now let's come over here and look at our second inequality. T plus 1 less than 4. Line down your inequality sign. I can subtract 1 from both sides. And we get t is less than 4. So our final answer is t is greater than or equal to 0, or t is less than 4. Go ahead and graph. Are you finding something cool? Let's see. So t is greater than or equal to 0. Go this way. Or t is less than 4. The entire number line is possible. All real numbers. So if we end up with an or, where the entire number line is shaded, this is an all real numbers situation. Number 9, lines down the inequality signs, focusing on the location of x. This is a positive 4 that we can subtract from both sides. So x is here in the middle. Don't change the inequality signs. You did not multiply or divide by a negative, so just keep it. 8 minus 4 is 4. 1 minus 4 is negative 3. Now, we said in our notes that when x is between two values, the direction is supposed to be this way. So it should stand out that this kind of looks backwards. So this becomes, literally imagine rotating this entire statement. So if this is going to come over here, if this is going to come over here, no, come on. So this becomes x is greater than or equal to negative 3 and less than or equal to 4. X is greater than or equal to negative 3 and less than or equal to 4. So this is like a massive rearrange. Let's graph. X is greater than or equal to negative 3, less than or equal to 4, and we're done. Number 10, process doesn't change. Lines down our inequality signs. Focus on the middle, because that's where x is. If there's something we can add or subtract, we need to do that first. Positive 6, we can subtract 6 from both sides. Negative 54 minus 6 is negative 60. I almost dropped this negative. This is a negative 6x inside. Less than 36 minus 6 is 30. The opposite of multiplying by negative 6 is dividing. We're going to divide both sides. When we divide by a negative, inequality signs change direction. But this is not okay. We're not done. Rearrange. So this becomes x is greater than, I'll keep it in green. This becomes x is greater than negative 5 and less than 10. So divided by a negative, and then we had to rearrange. Let's graph. X is greater than, strictly greater than, so open circle. Oops. Open circle on negative 5, and strictly less than 10. So x is between these two values. (11) We have two inequalities. If we start to lose track of what we have, literally see that word as the split between the two. This word is the split between the two. It also helps when we draw a line down the inequality sign, okay? Pay attention to where n is. We want to get n by itself. At this point for 11 and 12, as soon as I get started, if you feel like you can finish it, pause, try finishing the whole thing, and then jump a little bit, check your answer. If we match, move on to 12. So I'll subtract 4 from both sides. That gets me 2n is greater than 16. Divide by 2. Divide by 2. This gets me n is greater than 8. I'm done with this part. I'm going to go work on this side, this inequality. Here's n. If there's something I can add or subtract, I want to do that first. I can subtract 4 from both sides. So I get negative 3n is greater than or equal to negative 15. Divide by negative 3. Divide by negative 3. Inequality sign is going to change direction. We're going to flip it because we divided by a negative. So I get n is greater than 8 or n is less than or equal to 5. This will have two pieces. Greater than 8 or less than or equal to 5. Number 12 is our last skills example. Process does not change. Line down the inequality sign. But when I look at this one, check this out, just like what we did yesterday, I have variables on both sides of the inequality line. So remember the goal. We want to get x's on the left, numbers on the right. So if I just want x's, for me, I choose to move this I choose to move the negative 3 first by adding 3 to both sides. So I get 6x greater than or equal to 10x plus 8. This side, I just want numbers. So this 10x can't stay. I'll subtract that over. (6x minus 10x is a negative 4x greater than or equal to 8. Divide by negative 4. Divide by negative 4. We're dividing by a negative, so the inequality sign will change direction. X is less than or equal to -2. This half is done. Let's go look at the other part. Line down the inequality sign. Yet again, we have X on both sides of this line, so I'm just going to shift this goal over. It's not going to change. We want to gather X's to the left, numbers to the right. So let's see, just want X. 7X is fine. This -10 has to go. I will add 10 to both sides. So I get 7X greater than or equal to -2X plus 18. This side, I just want numbers. So this -2X, no good. Let's add 2X to both sides. Get it out of there. We get 9X greater than or equal to 18. Divide by 9. Divide by 9. X is greater than or equal to 2. This was an or, so let's finish writing the statement. X is less than or equal to -2, or X is greater than or equal to 2. Solid dot on -2, less is to the left, or greater than or equal to +2. (13 and 14 are some logical reasoning questions that we'll talk about tomorrow as a group. Our notes for tonight are complete. Great job. Please make sure that you have paid close attention to how you show work. Neatness is key. Tomorrow in class, we will be working on this practice. So this is tomorrow in class. At the start of class, I will be choosing one of these notes questions to be part of our notes quiz, along with one of the real-world questions that you practiced yesterday in class. Any questions? Please send me a message on Remind. Have a good night, everybody.